Hello everyone, ROCKMAN and ROCKWOMAN of Internet. Today I teach you trig, how to trig part 2. If you haven't watched part 1, please watch part 1. I will review part 1 a little bit in this video. So let's get straight to it. First we look at the grid. We have a 90 region, a 360 region, a 270 region, and a 180 region. Now all of these regions have like little territories that you call quadrants. So this one's the first one, this one's the second one, this one's the third one, this one's the fourth one. All right. So there are things called degrees that take over these regions, and it's important to know which way these degrees go so that you know where your borders are. I guess that's the easiest way to think of it. So first we have a degree, which is 310 degrees, and it's important to know that negative degrees go clockwise, so they go from here, which is your initial side. This is called your initial side, and they go clockwise, so they go like here and they go outwards. And this is wrong actually, because I messed up in the last video, and this is why I'm recording this again for like the third time, I believe. Yeah. So, all right. First, we need to analyze that. Well, which way is our coterminals going? How do we find our coterminal angles? Because we're trying to find our coterminals. Coterminal angles are angles that share the same terminal side. And to find them, we need to add or subtract multiples of 360. Now, you do this to find a negative and a positive coterminal. Sometimes a question might ask you to do positive and negative. Sorry, not positive. Positive, or negative and negative. In this video, we're going to learn how to do positive and negative. So we got the 670, which is our positive because we added, and then, boom. And then our negative is just negative, so we subtracted 360. So it's just negative 50. Now, we look at this negative 50 and we go, this clockwise. So our thing is here. Our angle is right here. So this is our negative 50. Negative 50. Now this is not our reference. This is our coterminal angle. This is our negative coterminal angle. And we got a 670. So with 670, it's clockwise, it's counterclockwise because it's positive. So we just take this thing from this initial side. We go counter. So one loop, 270, 270. No. So we need to go one more. We go one more loop-de-loop, and then we're there. Now we are at 670. So we got our 670 down here, and that's how you find coterminal angles. That's how you graph them too, because you're going to have to draw some of these sometimes. But essentially what they are is you add or subtract to find your coterminals. So let's say if you want to find two positives for coterminals, I believe it goes like this. Plus 360, like let's say this one, our example. So it's 670, right? Now, what's 670 plus 360? Well, I'm stupid, so I must look at a calculator. Clear? So we got 310. Oh, wait, no, actually, never mind. Sorry, it's 670. 670 plus 360. All right. 1030. That's our second positive coterminal if you want that. And then our second negative would be like if you also subtract like 360 from 50. So yeah, 360 from 50 is what's 50? What's 60 plus 50? I'm just joking. I know what it is. I just want to. I don't know what it is. Okay, negative 410. So negative 410. All right, there we go. So that is our double negatives, and that's our double positives if you need that. But positive and negatives just fine for any question almost. So now you might be asking, what is the point? Why? Just like, what's this leading up to? So essentially what it is the unit circle, which is this big round thing on this coordinate plane, and it basically just tells you a lot of things. So I'm actually going to draw it for you guys. So just a big circle. That's a really good circle. That's a really good circle. All right, guys. So we're gonna do the unit circle. Screw it. I'm just gonna put the unit circle. Big one. Big. This is really big. This is a really big concept, and it's pretty hard to understand at first, but you will get a hang of it with this caveman mentality. All right, all right, the first important concept is to know that coordinates that we're going to be discussing are cosine theta, which is x, and sine theta, so you're not lost, sine theta, which is y. Right, so in this quadrant, which is our quadrant 1, this is quadrant 1, these are all positive, so positive x and positive y, yeah. And here, essentially your cosine is positive and your sine is negative. And here your cosine is negative and your sine is negative, so negatives, two negatives. You got your cosine, which is negative, and you got your sine, which is positive in this quadrant number 2. All right, so quadrant number 3, I need to probably erase this. All right, quadrant number 4, this is quadrant number 4, so quadrant number 4 has a positive cosine and negative sine. All right, there we go. So that's like the most basic thing you need to know. Also, 90, 270, 360, 180 degrees. Now, these are turned into, what is the cosine? What is the cosine and sine of, like, let's say 90, right? Because 90 here, right? What's that? So the cosine and sine would be defined as this coordinate, right? So 0 and 1, right? So the cosine and sine of 90 is 0 and 1. So cosine is 0 and sine is 1. So it's just that. It's that simple. So the sine and cosine of, that line, that degree, that radian is the coordinate. It's cosine and sine, so it's 0 and 1. Like, let's say, let's do another one. So you got this one, which is 60, I think. Yeah, 60. So 60 degrees, and you got the pi over 3. 60 degrees is pi over 3, right? And the cosine of pi over 3, or 60, is actually 1 over 2 and root 3 over 2. So that is the cosine and the sine. And now we have the, what's it called, 45 degree. 45 degree is actually pi over 4. And then you have the 30 degree, which is pi over 6. All right. Now, what are the coordinates for these? You're obviously going to have to solve them here, like the sine and cosine of these. So this is why these coordinates are here in the unit circle. It's because it's easier to just identify them, like memorize them as of solving them to use in a grid. So 2 over 2. All right. So I'm actually going to show you how to solve for this stuff, because I know most people watching this video probably don't know how to do cosine and sine for this stuff at this point. I don't know, man. Anyways, let's do cosine of 45. cosine of 45. So cosine of 45, you look at it, you're like, okay, bro, it's obviously adjacent over hypotenuse. But what? What is this telling us? Like, what are you on about, bro? It's essentially this thing. It's essentially this triangle, the special right triangle that we did last video, and it's 45, 45, right? So you're like, okay, dude. All right, bro. Smart man, smart rock man. You think you know more than me? Well, in this part, probably. But this is x, and this is x, and well, and this is root 2 x. Oh my god, like that's the thing. So you look back and you're like, oh my god, my 45 degree is root 2 over 2 cosine and root 2 over 2 cosine. It's the same thing, because for 45, 45, 90, sine and cosine are literally the same thing. It's important to know how to solve it, or find it. That's what I'm saying, how to find it. So for our example, cosine would just be, adjacent over hypotenuse, which is adjacent, so x, over hypotenuse, which is root 2x. Yeah, so x's go out, and then that's just 1 over root 2. That does not make sense, so rationalize it. Because you cannot have a root in the denominator, you can't have a square root in the denominator. So when this goes out, that stuff goes, this turns into 2, this turns into root 2, so it's just root 2 over 2. See, it's so easy. Now the only thing you need to know is that in each quadrant, the signs of them are different. So for example, in this quadrant, sine would be negative and cosine would be positive, but cosine would be negative here and sine would also be negative here, and cosine would be negative here and sine would be positive here, and this one is just all positive. So it just depends what quadrant you're landing in, and it's going to be the same thing for if you want to find the cosine and sine of other degrees aside from that. Essentially, it's just you referring back to your reference angle, which we learned in the first part. Now this is very important because the reference angle literally tells you what angle or what special right triangle you're using. You're getting, like, you're supposed to use. So if you get 45 from subtracting 360 or 180, you get 45, 45, 90. But if you get 30 or 60 from subtracting 360 or 180 from the degree, then you know it's a 30, 60, 90. So, oh my god, what have we gotten to? Oh my god. All right, so here, essentially, this initial side is 0 degrees and 0, and this is 1 and 0. So the cosine is 1 and the sine is 0. 360, and you got 2 pi, which is its radian. This is the degree and this is the radian, just splitting them apart so you know the difference. So these are essentially the same, 2 pi and 360. It's literally the same thing, it's just in radians. Degrees to oh wait, okay, now this is really important. Degrees to radians, radians to degrees. Radians to degrees and degrees to radians is the most important part of this. Because you're thinking, like, how do I get here? How do I get from degrees to radians or radians to degrees? So essentially, radians to degrees is your degree, your radian, which is, normally a fraction, so let's just say pi over 2 times 180 over pi. Yeah, so just 180 over pi. And then essentially what this is telling you is just multiply it, bro. Like, literally, just multiply it. So in this case, we do 180 times pi, and then pi times. So it would just be like, what's it called? 130, 135, because let me calculator. All right. So we got 180 and then times your pi, right? So like in this case, we don't really have a pi like here, so just be. Oh wait, I did this wrong. What I meant to do, oh no. What I meant to do here, give me a minute. Let me find a better example because I kind of messed up on this one. All right. So let's do like the one that I was actually trying to mention, which is 3 pi over what is that, 4? Yeah. So this is 135 because 180 times 3 divided by 4 is 135. Yeah. So that's our 135, and so degrees to radians is just what's it called, pi over 180. So you just be like, let's do 100 degrees. 100 degrees times pi over 180 is, what is that, like 5 pi over 9. Yeah, 5 pi over 9. So this is just 5 pi over 9, because what you did was you multiplied. Sorry, you didn't multiply. You simplified this. So this would just be 5, and this would just turn into 9. So 5 and 9, and then you put this one on top, and then 5 pi over 9. That's how it happened. And now we're just gonna go back to the unit circle. So over here we got this thing, which is our first one, which is 330. 330, which is also 11 pi. What is that, dude? I literally cannot see my own writing. 11 pi over what? 11 pi over 6. 11 pi over 6. So 11 pi over 6 is just root 3 over 2 for the cosine, and negative 1 over 2 for the sine. And the same thing would go for the next one, which is 315. So 315, and then you got the, what's it called, 7 pi over 4, which is just root 2 over 2, and then you got the negative root 2 over 2. So it's just the same thing, and it goes around. So like this one. This one would be 300, and then this would be 5 pi over 3, and this would be just 1 over 2, and negative root 3 over 2. Yeah, that's it. So then you go to 270 here, which is, this is the big boy 270, and essentially what this is just 3 pi over 2. And then, but this one, the coordinate for this is actually 0, negative 1. So that means it has a cosine of 0 and a sine of negative 1. Now, if we go to this side, this degree, this side, let's do this. I'm sorry for the bad lines, but all right, let's go. So get started with our first degree, which is 240. And what is that? 4 pi over 3. 4 pi over 3, and then we have 225. So this is essentially just going up. So this is the least and this is the most. It's just going down, like going up from this side. So 5 pi over 4, and then yeah, so now we just write the coordinate for this, which is double negative, so root 2 over 2. This is also negative, so root 2 over 2. It's also negative. But this one, so this one is actually uh, 1 over 2. This is negative, still negative, all negatives. Root 1 over 2, and then we got negative root 3 over 2. I know this is not literally coherent at all, but if you search up a unit circle, you can see all of this. So it just essentially just keeps going around until this is filled. If you go search up online full unit circle, you can find a completed version. I'm going to use the one to my right for time's sake. So okay, evaluate using the unit circle. All right, how do we do this? So if it gives you evaluate using sine of 30. So all right, what do I do? Evaluate this. What is evaluating? So you look at it and you're like, brain, tell me. I draw a grid first. You got your 90s, you got your 360s, you got your, what is that thing? 270s, you got your 180. Just know this. Just have this in your brain. Hack it in your brain. All right. So sine of 30, we already know that 30 is on this side because this is less than 90. So it's 30. 30's here. And this is less than 360 here, and this is less than 270. All right. So this is our our angle, and from here, it's really important because our sine is 30. What that tells you is that this is a 30, 60, 90 triangle because it's a 30 degree. Oh my god, there's a 30 degree here somewhere. So it's 30 degree, 30, 60, 90. 36, 30, 60, 30, what is this? 60, 30, 60, 90. All right, there we go. So essentially what this is, let me just redraw our, what's it called? Our special right triangles. Our special right triangles go as follow. Our special right triangles, we got 30, 60, 90. So this is 60, this is 30, this is our 90, right? And what this is like, opposite to this, opposite to the right angle is our 2x. And adjacent to it is our root 3x. And opposite to 30 is our x. So our 45, 45, 90, because we're eventually going to see a problem like this as well, where it's telling us something that has a reference angle of 34, 45. So if it gives you something like just anything other than 30, like 60, 69, 70, 80, 85, 84, if it has a reference angle that is either 30, 60, 45, something like that, then you know it's either 30, 60, 90 or 45, 45, 90 triangle. So that's what we're using for our base here. This is our 2 root 2x. This is 45, 45, 90, 45, 45, 90. And I mean, I didn't draw that. This is both x's. So there's an x here, there's an x here. All right. What do we do with this? Like, so I'm just looking at this. Wait, but no, you have to use the 30, 60, 90. So it's telling you sine. So it's like opposite over hypotenuse. Yeah, that one. So our opposite here is x. So we got our x. And we got what's a hypotenuse? I don't know what a hypotenuse is. Just kidding. 2x. 2x. X's go out 1 over 2. So this thing here is 1 over 2. You could just do this mentally. You don't really have to. You don't really have to go through that process. I was just showing the anatomy. So it's just 1. This is 1. Because always the hypotenuse here is 1 when you're doing this. This is just 1. Just know that this is 1. The hypotenuse for this stuff is always 1. Because it's always x. But alright, let's go. So it's the sine of 30. We already found it. Sine of 30. of 30 is 1 over 2. You know, because we already found it. We already found it going through all of this. So this is actually the cosine, I think. So cosine of 30 would be adjacent over hypotenuse. So adjacent over hypotenuse would be, let's look. Adjacent is our root 3. So we got root 3 over hypotenuse. What is our hypotenuse? It's 2x. And there's x's here, so just cross these out. And then we got root 3 over 2. So that was what our cosine was. So we found our sine and our cosine for evaluating. So that's how you evaluate for sine of 30 or any number. Let's do any number now. Let's do like literally any number, and let's test our theory of how it actually works. So let's do a number. Let's do a number like I don't know, like sine of negative 2 over 2 pi 3 2 pi over 3. Let's do this one. So essentially what we have here is, you know, our grid again, right? And then the whole process just over again. It's just the whole process just over again, just looking at this. So first we know that by looking at our unit circle, or just by solving this into a what's it called? You know, a degree. You can do that if you want. So radians to degrees. So radians to degrees. In what we learned was radians to degrees is 180 over pi. So you could just do 180 over pi again to find that. But on our unit circle, we have a negative 2 pi over 3 over here. Yeah. So you draw our thing over here, and through finding all of the 45, 90s and all of that, you could tell what it is. And essentially this one is, I think this is a, what is this? What is this one? What is this? This is a 30, 60, 90. This is a 30, 60, 90, 100%. 30, 60, 90. All right. So from a 30, 60, 90 triangle, we know that we got a 2x, we got a root 3, we got an x. So if you want to find the sine of this thing, what you got to do is root 3 over 2. Because it's negative because it's on this side. It means that cosine is negative, so that's why this is negative. But that means that our sine is positive. So our sine for root 2 pi over 3 is what? Wait. I solved this wrong, boy. I solved this wrong, boy. This is positive. This is negative. So negative 1 over 2. And that is effectively how we evaluate for sine. You just memorize the unit circle, which is this. One more time. This is a good pattern to remember. It's literally a cheat code. So x plus y. So this is plus, and this is x minus y, minus x minus y, minus x plus y. Okay. What are we doing with this thing, bro? What is this? What is this? All right. So essentially for each part of these unit circle like this, there's a pattern. So you got 1, 2, 3. 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3. So if you want to memorize the coordinates, like the cosine and sine, the sine and cosine, you can do it. So like this. So essentially, when I say 1, I mean 1 over 2. And when I say 2, I mean root 2 over 2. And when I say 3, I mean root 3 over 2. And all of them are over 2. That's a reoccurring pattern here. So essentially, the sine and cosine of all of these would correlate to this. So I would say like 1, 2, 3, and then I'll be like 3, 2, 1. So that means that for our 60 degree, our cosine is 1 over 2, and our sine is root 3 over 2. And for our 45, it's root 2 over 2 and root 2 over 2. This is only for the positive side. When it goes into the negative side, you start applying the negatives, right? So then it would be like 3, 2, 1, and then 1, 2, 3. Yeah, that's how it goes. Yeah, 3, 2, 1, 1, 2, 3, 3, 2, 1, 1, 2, 3. And then from this side up, it goes 3, 2. Wait, actually, let me put this in order. So it's 1, 2, 3. 1, 2, 3, and then 3, 2, 1. So that's the coordinates for these. So this is just 3 over 2, root 3 over 2. This is root 2 over 2. This is 1 over 2. This is root 3 over 2. This is root 2 over 2. This is 1 over 2. And this is negative, negative. So both of these are negative. Both of these are negatives. Both of these are negatives. Like that. And it just goes on for like that. So let's just sort it in our quadrant again. So we got 1, 2, 3. 1, 2, 3. We got 3, 2, 1. We got 3, 2, 1. 1, 2, 3, 3, 2, 1. And then for this one, we also got 1, 2, 3. And we got, sorry, not this one. And we got 3. Oh my, why do I keep putting a dash here? I keep trying to think it's a fraction. 3, 2, 1. And this one is also 3, 2, 1. 1, 2, 3. All right, so it's really important to understand that the rules of these quadrants apply to these. So just let's go over it. 1 is 1 over 2. 2 is 2 over 2. And 3 is 3 over 2. That's my way of coding the sine and cosine, the cosine of theta and the sine of theta. That's how I code my thinking for this kind of setup. So now I remember every single coordinate for this unit circle, and our identifiers are positive x, positive x, positive x, positive x, positive y. We have positive x, negative y. And then we have negative x, negative y, and then we got the negative x and positive y. I'm so sorry, this is such a long video, but this is really important. So all of these rules apply to these. All of these rules apply to like this one. Positive, positive, all of these are positive, positive, negative. So that means that sine is negative. 1, 2, 3. So 1 over 2 is negative. Root 2 over 2 is negative. Root 3 over 2 is negative. That's essentially what it is. And so just memorize this pattern. 1, 2, 3, 3, 2, 1, 3, 2, 1, 1, 2, 3. And then you'll know the sine and cosine of each one corresponding to what sign it is. That's as simple as it gets. So I hope this was helpful. I'm so sorry. This was 34 minutes. 34 minutes of your life trying to learn trig. This is how I learned it. I'm sorry if this sounds like a crazed rambling, but this is how I understand it. So I hope you guys understand this as well. Essentially, the purpose of this channel is to make everything easier, but apparently it's a little bit harder to understand when you're literally caveman writing. So I appreciate you guys watching the video. I will timestamp this at 30, which is like basically the important parts. All right, bye.